Gauss Seidal method. Gauss Seidal method is an iterative method or an indirect method to solve the system of linear equations. Now consider the given system of linear equations. We'll use the Gauss Seidal method to solve the given system of equations. Now, to solve or to use the Gauss Seidal method, we have to check whether the given system is diagonally dominant. The system is diagonally dominant. Okay, to check the system is diagonally dominant, first we have to write the coefficient matrix of the system of linear equations. After writing the coefficient matrix, now look at the diagonal elements. The diagonal elements are 8, 11 and 12. Diagonal dominance means the diagonal element should be greater than or equal to the sum of the modulo of the other elements in each row. So considering the first row, we can see that the diagonal element is 8. So modulo 8 should be greater than or equal to sum of the modulo of other two numbers. The other two numbers are minus 3 and 2. Taking modulo, we get 3 and 2. Sum of 3 and 2 is 5. Now you can see that 8 is greater than 5. That means in the first row, it is diagonally dominant. First row is diagonally dominant. Similarly, check for the other two rows. For the second row, the diagonal element is 11. And you can see that 11 is greater than sum of the modulo of other two. Sum of the modulo of other two means 4 plus modulo of minus 1 is 1. So 4 plus 1, 5. So 11 is greater than 5. That means the second row is also diagonally dominant. Similarly, the third row. Here the diagonal element is 12. The sum of the other two we will get 9. So 12 is greater than 9 and the third row is also diagonally dominant. Now suppose the system is not diagonally dominant, then we have to make it diagonally dominant by changing the order of the equations. Okay, we just change the order of the equations to make it diagonally dominant. Now in this case, in the given question, we have a diagonally dominant system. So we can continue with the Gauss Seidal method. Now after checking for diagonal dominance, we have to convert or rewrite the given system of equations in this form. That is, from the first equation, that is 8x minus 3y plus 2z equal to 20, we have to write it in a form such that we get an equation for x. Now look at the given equation. From that, just I'll write it once again. We have the first equation as 8x minus 3y plus 2z equal to 20. Now keep the x variable on the left side and take all other variables to the right side of equal to. So we'll get 8x equal to 20 plus 3y minus 2z. Now from that we can say that x is equal to 1 by 8 into 20 plus 3y minus 2z. So we get an equation for x. Now like this way we will have to find equations for y and z. The equation for y, we will get it from the second equation in the given system, and the third equation will provide an iterative equation for z. So these are the iterative equations which we will be using to find the values for the unknowns x, y and z. So let's label each equation with an equation number. The first one is equation 1, second one 2 and third one equation 3. Now these are the iterative formulas that we have to apply to find x, y and z. Now taking the first iteration. So in the first iteration, we are going to find an iterative value or an approximate value for x. Now look at the equation of x. X is equal to 1 by 8 into 20 plus 3y minus 2z. That means to get a value for x, we need a value for y and z. Since we don't have any value for y and z, we assume that y and z is 0 and we start with that assumption. So in the first iteration, we will find the first iterative value for x by substituting 0 for y and z. So by substituting 0 for y and z, we get the first iterative value for x, and it is represented by the notation x, and put a 1 as a suffix for x to show that it's an iterative formula. So x is equal to, by substituting y and 0 for y and z, these two terms will go and we'll get just 20 by 8. That is how we got the first iterative value x1 equal to 20 by 8, which is 2.5. Now to find the first iterative value of y, we need the values for x and z. Since z we still don't have any value for z, we substitute 0 for z. But in the case of x, we just now found out the first iterative value for x. That value will be substituted here to get the first iterative value for y. So y1 will be equal to 1 by 11 into 33 minus 4 into the first iterative value for x. The first iterative value for x is 2.5. So 4 into 2.5 plus 0, which will give us 2.0909. Okay, so we to find the first iterative value for 1, we substituted 1 by 11 into 33 minus 4 into first iterative value of x plus z. The value of z was 0, since we don't know the value, so we substituted is 0 for z. Okay, like this we have to find the first iterative value for z. The equation for z is 1 by 12 into 35 minus 6 into x. Since we have the first iterative value of x, we can substitute that here. The same is the case for y. Since we have the first iterative value for y, that can also be substituted here, and hence find the value for the first iterative value of z. So by substituting, we will get 1 by 12 into 35 minus 6 into 2.5 minus 3 into 2.0909, and we will get the value 1.1439. This is how the iterations are done. So these are the first iterative values for x, y and z. Now similarly we have to go for the second iteration. For the second iteration, we use the first iterative values to find the values of x. Then likewise as we have done in the first iteration. Okay, so either you can write the iterations in this step-by-step manner, or to make it easy, we can write the iterations in a table. Now look, the table headings will be iteration, the iteration number, then values of x, y and z. So the first iteration 1, then x, y and z. The values of x, y and z will be what we have found will be written here. Now to find the second iterative value, for the second iteration we are using the same formula. The difference is that what we just got, that the value which we just found out will be substituted in the formula. So I write the second iteration formula for x, y and z. So second iteration, for the second iteration, that is x2 will be, the formula for x is 1 by 8 into 20 plus 3. Y, for y we have the first iterative value. So first iteration of y of 1 minus 2 into z of 1. This will give you the second iterative formula for x. Then for y, the second iterative value for y will be, the formula can be written as 1 by 11 into 33 minus 4 into x raised to 2. Since the last value for x we got is x of 2 plus z of 1. That will give you the second iterative value for y. Now to find the second iterative value for z, 1 by 12 into 35 minus 6 x of 2 minus 3 y of 2. So these are the formulas which will be used in the second iteration, and we'll get the values as shown in the table. Okay, so in the case of third iteration, the formulas will be x of 3 equal to 1 by 8 into 20 plus 3 into y of 2 minus 2 into z of 2. And for y of 3, we'll get 1 by 11 into 33 minus 4 into x of 3 plus z of 2. And z of 3 will be 1 by 12 into 35 minus 6 into x of 3 minus 3 into y of 3. This is how the formula goes on, and you will get the values like this. Now the iteration will stop when for the last two iterations the values of x, y and z will be same up to the desired number of decimals. Now look at the iterations. For iteration 5 and 6, the values of x, y and z are same. In the case of x, 3.016 and 7 we got, right? So we can write that 3.016 if we are taking the first three decimals. Okay, 3.016, or in the next case also you can write the last value, just take the last values, that will be fine. And the y value will be 1.9859 and the z value is 0.9118. So these are the values for the unknowns x, y and z which we found using the Gauss Seidal method.